all of it, all of the things in the universe, and especially it would have to explain everything that we have learned from quantum mechanics as well, even though quantum mechanics is kind of bizarre and has some specific and bizarre properties of these particles that we have seen, such as spin and etc. So quite a bit has been learned about the universe, about the nature, through quantum mechanics and the scales of quantum mechanics, which is, of course, the very tiny scale of a particle scale, subatomic scale, right? Some of these particles we're mentioning are really quite small, like lepton. An example of a lepton is an electron, which is, of course, inside the atom and sort of orbiting the nucleus. An example of the next type of particle family, quarks, is very tiny. They exist within a proton or a neutron. Protons and neutrons are made up of quarks. And then the last type of particle family, boson, is things like photons, W plus, W minus, Z naught, and other things such as maybe the graviton, if we found the graviton, or Higgs boson, those types of things. So basically, this the elementary particles, or the standard model of particle physics, comes from the success of quantum mechanics, if you will. If quantum mechanics was not successful and it had been killed earlier on in the 20th century, then we would not see it sort of thriving and thriving and thriving and thriving beyond what it was able to do in the 1920s, let's say, and keep on going until we see it really thriving towards the end of the 20th century, and more particles being discovered and particle physics coming out of it. So that's why we talked about, Stephen Hawking wrote a whole chapter on particle physics, pretty much. Actually, a couple of chapters, because he had the uncertainty principle chapter that we covered a couple of days ago. That's really sort of an introduction to quantum mechanics for you. And then the next chapter, elementary particles and the forces of nature, is really, in a nutshell, particle physics, which would not have developed if quantum mechanics had not been allowed to thrive. Doro, hello. Thank you so much for joining. Thank you so much for being here and liking the live. 5-hour water break. You mean hour? So this is sort of to kind of bring together all of the things really in the universe. So on the one side, we have general theory of relativity giving us an updated theory of gravitation and telling us a lot about the universe and how it works. And then on the other hand, we have quantum mechanics and its developments, which gave us particle physics, which is also extremely important. And together, we might learn more. And if you're really trying to unify everything, you would find a way to subsume general theory of relativity and quantum mechanics at the least, because these two theories sort of don't always agree. And certain things are kind of missing in general theory of relativity, and certain things are kind of missing, or at least very bizarre, in quantum mechanics. If you talk to a true quantum mechanics advocate, they might not agree that it's incomplete, but they will probably agree that it is kind of bizarre. The uncertainty principle, the probabilistic nature of it, were things that people really struggled to accept when it was first kind of coming out. But at the same time, even though people struggle to accept these things, they very much hold true even to this day. Because if they didn't, we would not have Aapka number kya hai? Somebody asked. She's already married to a microwave. That is true. There is a microwave that I'm quite committed to. So basically, all of that is to say that there's some drama in quantum mechanics, but it survives, it thrives, and it gave rise to particle physics, which I think was difficult for a lot of people to accept, but it thrives. And we talked a bunch about that for the last couple lives when we covered that chapter, elementary particles and forces of nature. That's basically particle physics. So now, now, that's true. You missed a massive 4-hour water break. So now we will talk about black holes. Now, as you know, black hole is another example of a singularity. the Big Bang